In this video, we will solve a numerical problem on homogeneous functions. The question is, which of the following functions has a degree of homogeneity not equal to unity? We are being given four options. We need to find out the correct option. Okay. By homogeneous of degree 1, what we mean? A function is said to be homogeneous of degree 1 if independent variables are multiplied by a constant value, then the dependent variables are also increased by the same value. Simple thing. Let us say if we have a function, let us say we have a function f is a function of labor and capital. Okay, this function is said to be homogeneous of degree n if if we multiply each input by lambda, let us say L lambda k, and if we get lambda raised power n f of L k. Okay, so this function is said to be homogeneous of degree n. Okay, if this condition holds. Now let us see what happens if the value of n is 1. So we have homogeneous of degree 1 or unity. If the value of lambda, sorry, the exponent is 2, so we say the function is homogeneous of degree 2. Okay, now let's take the case one by one. So in the first case, let us write it in this fashion. Q is a function of capital and labor here. Okay, we have 100, k to the power 1 upon 4, L to the power 3 upon 4. Okay, now if we multiply each input by lambda, that means q, uh, we increase capital by lambda and labor by lambda, then what will happen here? We have 100 in place of k, we have lambda k to the power 1 upon 4, and we have lambda L raised power 3 upon 4, and we can write it in this fashion: 100 lambda raised power 1 upon 4, k to the power 1 upon 4, then we have lambda raised power 3 upon 4 and L to the power 3 upon 4. We can add up the exponents of lambda, so it will become lambda 1 upon 4 plus 3 upon 4. Bases are same, we can add up the exponents. It becomes only lambda raised power 1, and we are left with 100 k to the power 1 upon 4, L to the power 3 upon 4. I hope you understand what I am doing here. So we get lambda raised power 1. So this whole stuff is equal to q. Okay, because q is this stuff, that means q lambda k lambda L comes out to be lambda raised power 1 q. So this first function is homogeneous of degree 1. Okay, now let's take the case of next function. Same logic can apply here. That means we have been given q is equal to 20. Rather, let's write q as a function of capital and labor, which is equal to 20, k to the power 0.5, L to the power 0.5. So let's multiply each input by L, rather lambda. So we have q lambda k lambda L is equal to 20. In place of k, we have lambda k raised power 0.5, L. In place of L, we have lambda L raised power 0.5. Here you can also see it becomes 20 lambda raised power 0.5, k to the power 0.5, lambda raised power 0.5, L to the power 0.5. Again, lambda into lambda, bases are same, we can add up the exponents. So exponents add up to 1, so we get lambda raised power 1, 20, k to the power 0.5, L to the power 0.5. And here you can see our q, k, when each factor is multiplied by lambda, our output also gets multiplied by same factor. That is, this function is equal to q. So let's write it here, q. So the second function is also homogeneous of degree 1. Now let's take the case of third function. In case of third function, and let me write it here. So let's write it in this fashion: q k L. Here if you can see, it is a square plus 2ab plus b square. So it is of form a plus b whole square. So I can write it in this fashion: k plus l raised power 2. Okay, simple mathematics here. So let's multiply each input by lambda. So we have q, lambda k, lambda l here, and here since we are increasing each factor by k, so here we will have lambda k plus lambda l square. So we can take lambda common, so we are left with k plus l. Okay, it is whole squared. So we can write it in this fashion. If we expand it, it will become lambda square, then k plus l square. Okay, so here again what we got, when each factor was multiplied by same factor, sorry, when okay, so when each input factor was multiplied by same factor, output was more than, output increased more than the same factor. We have lambda raised power 2 in place of k plus l raised power 2, we have q. Here you can see clearly that this function is not of homogeneous of degree 1, because when each factor was multiplied by lambda, our output got increased by lambda square. So this function is of homogeneous of degree 2. Okay, homogeneous of degree 1 gives us constant returns to scale, and homogeneous of degree 2 gives us increasing returns to scale. This should be remembered here. Let's take the last one. So again, first two are the Cobb-Douglas production functions, and let us see last one. We have d. Q is a function of capital and labor, which is equal to, so this can also be written as k plus l square raised power 1 upon 2. Okay, this step comes out to be a plus b whole square, and it is raised power 1 upon 2. So 2 and 2 gets cancelled. So actually our function is k l is k plus l. So we have linear production function here. Let's multiply each factor, input factor, by lambda. So we have here lambda k plus lambda l, which comes out to be, let's take lambda common, so we have k plus l. Again you can see when each factor was multiplied by lambda, here we got output got multiplied by same factor, that is by lambda. So here we got lambda raised power 1, a plus l is equal to q. Okay, so this last function is also of degree 1. Okay, I hope I make myself clear in this video. Thank you.